Hello, you are welcome. This is a velocity time graph here, and we are told that from the velocity time graph below, find the total distance covered. Now, from a velocity time graph, anytime you want to find the total distance, what you just need to do is to find the area covered by the shape. The area covered by the shape. Now, if you look at this shape, I can categorize this shape into two. I have this shape here. I can call this part A, and I have this shape here, and I can call this part B. Now, the shape A, you agree with me, is a trapezium. That is this shape A here. Then similarly, the shape B here is also a trapezium. You can see the long parts, and this side slanting downward and then back to this place. This is the vertical part now. This is a vertical trapezium. And then this one, we have the two sides that are slanting. So this is a trapezium A, and this is trapezium B. Now, in trapezium A, we can find the top part, because don't forget that the total distance is the area formed by the shape. And the area of a trapezium, which is the distance covered now, is given by the area of a trapezium, which is half sum of parallel side, which is A plus B, multiplied by the height. Now, if you look at this shape now, the upper part, this is in this first shape, there is the trapezium A now. This part is the portion that is called A, small letter A. And you agree with me that to get this distance, we simply say 11 minus 5, and that will give us 6. So this distance from here to here is 6. That is 11 minus 5 is 6. And that is also equal to this top, because this length here is also equal to this length. So I have my A as 6. And then my B, that is from here down to this place. This is 14. And this is 0. So 14 minus 0 is 14. So this full length here, 14, is also equal to this length from here to here. So I can say my B for this trapezium A is 14. So I have the B part as 14, and I have the A part as 6. Then the height of this trapezium A, this is the height of trapezium A. So the height of trapezium A from here to here, and that is from here to here as well. So 15 minus 10 will give me 5. So this is 5. Oh, sorry, this point is supposed to be 25. This is a mistake. This is supposed to be 25, not 15. So 25 minus 10 is 15. So I have this point as 15. So I can now substitute values. So the height of this trapezium A, the height is this point here, which is 15. And that is the height of the trapezium. 25 minus 10 is 15. So I can now substitute values, and I say 1 over 2 multiplied by the value of A. And the value of A is 6. That is multiplied by 6, plus the value of B, which is 14. That is from here to here, 14. Or multiply by the height of this trapezium, which is this 15 here, multiply by 15. And I can work further, and that will give me half multiplied by 6 plus 14 is 20, and then multiply by 15. So this part is going to give me the distance for A now. So I can say I'm using A now. So the distance for A will give me 10 multiplied by, that is 15, that is 150, or 20 multiplied by 15 is 300, and divided by 2 is 150. 150 meter. So the distance on this part here is 150. So now, that is for trapezium A now. So we are through with trapezium A. That is the distance of this portion. And that is what gave us 150. Now we are going to trapezium B to find the distance of trapezium B. Now, to find the upper distance, that is from here to here, is simply 18 minus 0. So this portion A for trapezium B, I have A, will be equal to 18. That is 18 minus 0 is 18. And then the B part, which is from 0 to 20, that is the base now for this, will be this last value. Don't forget this last value, which is 20. Excuse me. So B is equal to 20 in this second trapezium. And A is 18. Then the height for this second trapezium is 10. That is from 0 to 10. So the height is 10. So let's do that for the second trapezium. Excuse me. Now, for trapezium B, I say distance is equal to half multiplied by A. The A part for trapezium B is 18. As you can see, that 18 plus the B part, which is 20. That is B now in trapezium B is 20. And then multiply by the height, which is 10. So simplifying that further, we have 20 plus 18 is 38. So I say half multiply by 38 and then multiply by the value that I have here, 10. And then 38 multiplied by 10 is 380. And 380 divided by 2 will give us 190 meters. So the area covered by the portion, back to the graph now, the area covered by this portion, which is trapezium B, is 190 meters. That is the distance covered by this portion. And the distance covered by this portion A, as obtained, is 150. So the total distance covered by the body will now be 150 that we obtained for A, added to 190 that we obtained for B. That will give us the total distance that the body undergo. So we can now say total distance will be equal to the 150 that we got for the first trapezium added to the 190 that we got for the second trapezium. And the two together will give us 340 meters. So the total distance covered by the body is 340 meters. Hope you enjoyed this video on velocity time graph. So please don't forget to share and then also like this video and subscribe to this channel if you have not done so already. Thank you for watching, and I'll see you in my next video.